Hey everybody, today we are going to start almost a new book, not a new chapter, but a new topic, electricity and magnetism. This is where you're going to find a lot of good problems. Um, and if you're not comfortable with vector or doing simple integrals, it becomes really hard to do problems in electricity and magnetism. So I'm going to do problems so if you can actually learn to do it that way, it might help you avoid lots of mistakes, simple mistakes. Okay, so here is a very simple problem. I have four charges, the cone of a rectangle, 3 centimeter, and this is a totally fictitious problem because for the charges to be like that, you have to say these rods are non-conducting, connecting rods, or somehow these charges have been placed there static, and they are point charges. So these are first thing notice is they are point charges. So you should definitely understand what point charges are, and you can go to this my website there, and you can study more about what point charge is. It's just a model of elementary charge. Okay. So point means I can assign a coordinate, like XYZ coordinate to the location of charge. But the charge is not spread out. It can be said is to be exactly at this point at this time. Okay, so we're going to do what is Coulomb force on this one. Question says, what's the Coulomb force on this by these other three? Okay, so first you have to know what a Coulomb force is, and there are many ways you probably learned Coulomb force, and let's review a little bit. Coulomb force between electric charges, Q1 and Q2. Usually you just say it can be plus or minus, this can be plus or minus, positive, negative charge. If it's a positive charge, I'm going to assign a positive number to that. If it's a negative charge, I'm going to assign a negative number to that. So first thing to say is, because it is a force, it's going to be a vector. So it's going to have a rule for magnitude and a rule for direction, right? So the magnitude will be a constant K. I'm going to come to it, Q1, Q2, and then I'm going to make it absolute because it's magnitude, so it's going to be positive. R is the distance between them, R square. So that's why it's called inverse square law. So that's why it's another way to remember this inverse square law, because of this being squared. The direction, you use like charges repel, opposites attract. Already see this is too abstract, you can't do any math with that. So for instance, because this is a force, so if you had a whole bunch of things, say you had a 1 to n charges, and you wanted to have force on one by all the other guys, so force has to be on a particular one. This is going to be force by 2 plus force by 3, force by n, right? All the other charges will have the, and this is a vector addition. You can see this law here makes it really hard to do the vector addition. So the way I like to think about it is this law, you can think more analytically. Means you're going to have some kind of coordinate system. So in that coordinate system, say q1 at x1, y1, z1, and q2 at x2, y2, z2. Okay, so I can write f on, say 1 will be k q1 q2. Now signs, okay, signs allowed, r square, and then for direction you have a unit vector. If it's on 1, then on to by direction unit vector. So here on is, there's only 2 charges. So in this example, so on is 1, so it's 1 to 2 direction. So if 1 was here and 2 was here, this unit vector is in that direction. So if this is positive, this is positive. Let me see. If this is positive, then you want the force to be opposite direction. This should be 2 to 1, right? So it should be, this is 2, so unit vector will be that direction, 2 to 1. So if this is positive, then the force on 1 should be in that direction, same direction you had. So this is by on. Okay, so this is the way you can use this rule to actually check your answer. So if this is positive and this is positive, then this should be in the direction of the force. So if I'm looking for on 1, then it should be repulsive force. So 1 is repelled away from the 2. Okay. So now if this is 1 and this is 2, and so this is positive but this is negative, and you had in that direction, then the force will be, as you can see, if this is positive and this is negative, then the force, when you multiply the minus sign, and so you flip the direction of this guy, and correct direction is the force will be in that direction. So this, as long as I can figure out this, I also know the direction. So when I bring it over here, it will be force by 2 magnitude. So the magnitude part, no, I just, the whole thing I can write down. I can write down, this would be k q1 q2 over r12 square. That's the magnitude part with the sign, and then u, and I go 2 towards 1, 2 towards 1. Then I get k q1 q3 over r13 square. You had 3 to 1, and so it just becomes a vector addition at this point. Very simple. Okay, so we need to know what the unit vector will be. So in here, unit vector, if I go from here to there, so it is 1 and 2, and unit vector we want is in that direction. So if you look at in terms of, this is r1 vector and this is r2 vector. So r1 vector is x I hat plus x1 I hat, y1 j hat plus z1 k hat, right? And r2 will be similarly. So this one is r vector from here to, I want this direction, so this direction vector I want. So this plus this equal to that, so r plus r2 equals to r1. So r vector is r1 minus r2. Okay, so because I can go to this place, going here and then there, or go directly. So u vector is the unit vector of this guy, so r1 minus r2 over r1 minus r2 magnitude. So that will be the unit vector, u from 2 towards 1. Yeah, okay, so we go 2 towards 1. Okay, so so from where I start is the negative part. Okay, and now I'm gonna use this idea to solve that problem. Okay, so here is a summary of Coulomb's law written analytically. You know, it's in this form is much easier to apply to more complicated situations. Okay, and when we do more advanced problems, this way of writing actually helps you generalize much more quickly. Okay, so it's better to get used to writing like this and symbols. I know this is initially you have to really try harder, but then once you get used to it, it's much easier. It helps. So let's see how it helps. So I'm going to do one my way. I'm sure there are many ways of doing this problem. This is so elementary. You have your own way probably of done these problems. So I'm looking on this. So I need to figure out from 2, from 3, and from 4. So f on 1 by 2. Now writing these vectors, probably it's easier if I choose a coordinate system where this is origin. So usually wherever the 1 is, choose origin there, place origin there. That's my strategy. So I'm going to place origin here and take one of the charges along the x-axis, and in this problem there's just other one is y-axis, and there's nothing, everything in xy plane, so all the vectors will be very simple. So I have we didn't talk about k. K is actually 9 times 10 to the power 9 in SI units or MKS units, and this is equal to 1 over 4 pi epsilon naught, and epsilon naught is electric susceptibility of vacuum or something called empty space. I say universal constant because there's only one vacuum. If you look at the units here, this is Newton, so this will be like, you don't have to remember the units, but if you want to look, this will be Newton, and you have to divide by Coulomb square, Newton over, and this will go on the meter square over Coulomb square. So that's the unit that will be based on this. Okay, so going back here, I have K. I'm just going to leave those things K, and Q1 is 2 microcoulomb. It's 2 times 10 minus 6. Q2 is minus 3 times 3 to the power minus 3 to the power minus 6, and the distance between them is 4 centimeters squared, so 4 times 10 minus 2 square, and let's make it 9 times 10 to the power 9. So this is from f by 2. F by 2, something happened. So f by 2 in terms of this part, and then I need to have the unit vector, right? So I want unit vector in that direction. So I really don't have to do all of this. If I do all of this in this problem, is kind of overkill. This one is just minus I hat. So you can see minus with a minus becomes plus, so the force will be in the I hat direction. So you might have another way of doing it, but I tend to take out all the powers of 10 in one place and everything in another place. So 9 times 2 times 3, and this is 16 times 10 to the power 9 minus 6, and this will be plus 4. So and the direction is minus with a minus, we can plus I hat, and this one will be, you can see that this 13, this 12, so this is just 1, and you can simplify it. I'm just going to leave it as it is. So F on 1 by 3 is a little bit harder to do, but let's do 4 first, and then we'll do F 1 by 3. So the second is going to be kind of almost all of this same. You can see you can put all of this or just say what the difference is. So you can, how do I change this to that? But let's work out hard way. For K1, so started except 3 centimeters is 4 centimeters, so 3 times 10 to the power 2 square, and again I need that direction for unit vector from to, right? This is the I want the force on this, force on 1, so that's going to be minus j hat, and again this cancels that, and so it's attractive, so it's going to be 9 times 2 times 3 times 10 over 9 j hat. Now these guys, forced by that is going to be 9 times 10 to the power 9, 2 times 10 to the minus 6, and this also 2 times 10 to the power minus 6. They have the same according to here. Okay. And the distance between them is, if this is 4 centimeters, so this will be 5 centimeter. So I have a 5 times 10 to the minus 2 square. And I want the vector in that direction. So you can see it's going to be x1 minus x3 I hat plus y1 minus y3 I hat, and square root of these guys, x1 minus x3 square plus y1 minus y3 square. So these guys are 0, so this minus x3 I hat, so this is minus x3. So this guy's coordinate is 4 and 3 in centimeters, so minus 4 I hat minus 3 j hat over 5. So I get, you can see how all of this, only difference will be over here, 9 times 2 times 2, and this will be 25 instead of 9 or 16 times 10, because all this thing will be exactly identical. And this is minus 4/5 I hat minus 3/5 j hat. So now I need to add these guys up, this, and this, right? Okay. So the F net will be, after I add these up, it will be sum a I hat plus b j hat. Actually, is if if these guys are positive, in terms of positive negative, this will be minus this and minus this, because I think this would dominate, so this is going to be, it's going to be like this. Okay, I'm not going to work this out fully for you, but sign will turn out like this. Okay, so I'm just going to say I found some sign, so let's just call it some x I hat. So let's call it fx I hat plus fyj hat. That's some signs over there, right? So how do I get the magnitude? Magnitude will be, f net will be square root of fx square plus fy square, and direction will be, you know, say these guys are plus, so if this is, it will be over, which is not the case here. Here more like it's over here. So if it's over here, then you get an angle theta. If it's over here, usually you want to give this as a theta. Okay, so theta, this or this will be arctangent, and because arctangent has a problem, right? So you need to be able to work it out, right? Okay, so I will complete this for one, and maybe you can do two on your own. Let me complete this for you and come back. So I went ahead and found a value for this, value for that, and value for this, and then I added them. So fx comes from here and here, and fy comes from here and here, and then I found the absolute value, and I found that both of them are in the first quadrant. So it's more like this situation, and then I figured the angle out, and so this will be the final answer for this problem. Now you have to go out and do this on your own. So you can either put the Q2 at the origin and create a new set of problems, a set of axes. So I normally like to avoid trouble, and this is what I want. So I'm going to create a new axis, x and y, like that. And so this is the number 1 now. I mean, this will be the number 1, and this is number 2, and the origin will be at the number 2, and this is the number 3, and this number 4. And a lot of these values can be reused because this problem is repeating, right? So you may not have to do all the work, but you should practice on that. Okay, and you don't need my answer. Whatever answer you get, you should be able to repeat it and check it for yourself. That's a good idea, to learn how to check the problem's answers by yourself. Although I didn't check it here, but I want to just illustrate the procedure here, and I've done this problem on the first time. I don't have an, if I were to check it, I would do it again and make sure I got the same answer. Okay, that's it, and I hope you take a journey with me. It's going to be 4 months now that I'll be doing only electricity and magnetism problems. So if you have some favorite electricity and magnetism problem you want me to solve, you can just leave it in the comment below, and when I get to it, I will definitely keep that in mind. Okay, take care, bye.